right, so again, we're going to go over the practice problems that you guys have been working on in class the last couple of days. Of course, if you have any questions, you need to speak up and ask or type them in the chat box or whatever. And Miss Hall and I are both here and ready to help out. So I'm going to go ahead and get started with number 1. It says, a chef prepared a pan of Hello Dolly bars and divided it into 24 equal bars. So the first thing we know is that there are 24 bars in total. Next it says he sold 3/4 of the bars in the first hour of business. So 3/4 of the bars were sold. And then the questions are, calculate the number of bars sold and the number of bars left. So how many bars were sold and how many bars are left? Okay, so just as a kind of a refresher before I actually start on this problem, I want to remind you that that all of these problems that we've been working on here that are fraction, decimal, or percentage problems, they're all the same idea. It all boils down to you're looking at a part of the whole, okay? And so there's different angles that I can ask you questions about them, as of course you're going to see this whole front side of the page is all the same type of question, just coming at it from different angles, dealing with the percentages and the fractions and that kind of thing. So we want to know 2 things about this problem. First, we want to know how many bars were sold, and then finally we want to know how many bars are left. So we need to figure out first the bars that are sold. Well, the problem tells us that 3/4 of the bars were sold. Okay, so I'm going to multiply 3/4 times the total number of bars. Okay, 3/4 times the total number of bars. And then again, you guys can do this. You certainly don't have to if you don't want to. It's whatever's most convenient or comfortable for you in terms of what you're doing. But you can always write a number over 1. So I did that just so that you can kind of see we're multiplying fractions here. And when we multiply fractions, remember you multiply across the top, you multiply across the bottom, and then you divide at the end to get your answer. Unless, of course, you recognize that you can do some simplifying within the problem to make life a little bit easier, which of course I recognize here. Instead of getting my calculator out, I can do this math in my head because 4 goes into 4 once and 4 goes into 24 6 times. So I'm going to do that little reducing trick right there. And then I just have to multiply 6 times 3, which is, of course, 18. So 18 bars were sold. So that takes care of the first part of my problem. Okay, 18 bars were sold. 3/4 of 24 is 18. And that 3/4, that's the part that was sold. So 18 bars were sold. Now, if I want to figure out how many bars are left, remember, whenever we're dealing with a part of the whole, the total is equal to the sum of the parts, right? No matter what the problem is. If we have a total and we have parts, then the total is always equal to the sum of the parts. Well, in this case, the total is my 24 bars, the whole pan of bars. And then the parts are the parts that were sold and the parts that were left. So I can kind of rearrange this, okay, to be the total minus what was sold will give me what is left. And so the total number of bars was 24, and we sold 18 bars. That means that there are 6 bars left. Okay, anybody have a question about how I did number 1? All good. All right. Thanks, Naija. Appreciate your response there in the chat box. Now, again, also let me just mention this as I'm moving on here, preparing for number 2, and that is that, could you have attacked this problem other ways? Yes, absolutely. The way I'm showing you is not the only way to do this problem, but it is the way that seems the most logical to me. Okay. So number 2 is a similar type of problem here. A chef prepared a cheesecake and divided it into 12 equal slices. So we have 12 total slices of cake, cheesecake that is. And he sold 2/3 of the cheesecake during the lunch rush. So 2/3 was sold. Calculate the number of slices sold and the number of slices left. So how many were sold? How many were left? Okay. So we're going to kind of attack this problem the same way we did the last problem. We've got the sum of the parts equals the whole. The parts are what were sold and what was left, and we know the whole. So 2/3 were sold. So I'm going to multiply 2/3 times the whole. And I'm going to put that over 1. Again, you don't have to put it over 1 if you don't want to, but you certainly can to make life a little bit easier for you. And then again, I'm going to do some reducing here. I know that 3 goes into 12 4 times, and 2 times 4 is 8. So 8 slices were, again, sold, right? That's the part that we were working with. 2/3 was sold. Okay. We could then calculate the number of slices left the same way we did in the previous problem. If there were 12 slices total and we sold 8, that would leave 4 slices. Again, there's other ways that you could go about solving this problem. For example, I could kind of look at it from this perspective. Whoops, that didn't really work according to my plan there. If I sold 2/3 of the cheesecake, that means that 1/3 of the cheesecake is left. 1/3 of 12 is 4 slices. So again, I'm just trying to show you there's different ways here to go about solving this problem. Whatever way makes the most sense to you, that's what I want you guys to do to be successful. Anybody need to ask me a question about number 2? Okay, number 3 says a chef prepared a decadent chocolate cake and divided it into 20 equal slices. Okay, 20 slices total. At the end of the day, there were 3 pieces left. So 3 pieces left at the end of the day. What percentage of the cake was sold? So again, just like the first 2 problems, this is a percentage problem, parts of the whole, if you will. Okay. And I think that this problem, I can make this problem very, very easy for you if I draw a picture. Okay, there's my 20 equal size slices. And they're all equal. Right, class? Say yes. Thanks, Will. I know I'm not a great artist, but I'm trying. Okay, so take note. Here's what I'm going to do. There's 3 pieces left. So this is like the original, what the cake might have looked like. And then I've got these 3 pieces right here. Those are the pieces that are left. Okay. So the question is, what percentage was sold? So this time, as I'm looking at my part, the part that I'm interested in is the part that was sold, not the part that's left. So I need to figure out what part was sold in order to calculate this percentage. So how do I determine how many slices were sold? Well, there was 20 slices to begin with. There are 3 slices left. So that means 17 slices were sold. You guys agree with that? Yeah. Good. I just got in the chat box there before I even got it written down. Yeah. So 20 minus 3 is 17. So that's the part that we're interested in. There were 17 slices sold. There were 20 slices total, right? So again, parts of the whole, the part that I'm interested in is the part that was sold. That's 17. And then the whole is my 20 slices. That's how much the original cake had in it. So all I have to do is divide 17 by 20. Now, of course, that gives us a decimal. And don't forget that in order for us to actually have a percent, we always have to multiply that decimal by 100. So this equals 85%. Okay? So 85% was sold. Anybody have any questions about number 3? And let me just point out to you guys that, again, could I have gone about solving this problem a different way? Sure, I could have calculated the percentage of the cake that was left and then subtracted that from the total percent, and that would have given me the percent that was sold. There's different ways to go about the problem. But this is just one of the ways that you could come up with the correct answer, okay? All right, number 4. A chef prepares ice creams in 2 different flavors. Calculate the number of customers who preferred to have vanilla if 40% of the 375 customers had chocolate. Okay, so let's figure out here what we know. Well, we know that 40% had chocolate. Okay, you guys hopefully can glean that from the problem. We also know from the problem that there were 375 total customers. And then the question is asking us, calculate the number of customers. So what's the number of customers that had vanilla? All right, I don't think I need to say this, but just in case, okay, this little symbol right here that you guys tend to call a hashtag. I don't even know what hashtag means, but in mathematics, that symbol represents the word number. So that says the number of customers that ate vanilla. I hope you guys recognize that, okay? The number of customers that ate vanilla. That's what the question's asking us to solve for. So again, there's lots of different ways that I could go about solving this particular problem. Here's the way I'm going to do this first problem. I'll do the first one differently than I do the second one, I think. Okay, but what I want you to recognize is that the first problem, we were given a percentage that ate chocolate. Well, again, thinking about percentages, we've got parts of the whole. So the total number of customers is equal to the percent that ate chocolate and the percent that ate vanilla, right? So if I want to figure out the percent that ate vanilla, all I have to do is subtract that from the total. So the total number of customers, or the total amount of customers, is 100% minus the 40% that ate the chocolate, and that will tell me what percent ate vanilla. And of course, 100 minus 40 is 60%. So 60% of the customers ate vanilla. Okay. Now, I need to know how many customers 60% is. Well, we can do 60% of 375. But before we do that, remember that you always have to divide a percent by 100 to get rid of that percent label and actually use it in a problem. So when I work out the problem here, what I really have is 0.60 or 0.6, you really don't need that second zero, times 375 customers, and that will tell me how many customers ate the vanilla, because that's 0.6 is the 60% that we calculated. So 60% of 375 is 225 customers ate vanilla ice cream. Okay? Anybody need to ask a question about how I did number 4? Keeping in mind, again, that you may have done it differently, and as long as you got 225 customers, that's fine, because there are lots of different ways we could go about this problem. In fact, I think when I did a sample problem for you guys yesterday, I think I showed you like 4 different ways that you could attack a problem like this. All right, I'm going to move on to number 5. Nobody said anything or typed anything into the chat box about having any questions. So here's number 5. Okay, number 5 says calculate the percentage. So I'm looking for a percent. What percent? Calculate the percentage of customers who prefer to have vanilla. So what percentage of customers ate vanilla? In the previous problem, if 192 customers had chocolate. So 192 customers had chocolate. And since they referred us back to the previous problem, I know what the total number of customers was. It was 375. All right. So what percentage ate vanilla? Again, all kinds of different ways that I could go about solving this problem. What I was given was the chocolate, so I know the chocolate part of the total, but what I'm asked about is the vanilla, so I need to find the vanilla part of the total. So, you know, I could go about doing this by subtracting, and I think that's what I'll do. I'm going to subtract the part of the whole to figure out what part was the vanilla. So 375 customers minus the 192 that ate chocolate will tell me how many customers ate vanilla. And that's 183. Okay, so now I know the part that ate vanilla. So now I just need the whole, which we already know is 375 total customers. And then that will allow me to do my percentage. So 183 customers divided by the 375 customers works out to be about something like that. But of course, remember, the question asked me for a percent, so I have to multiply this by 100 to get my percent label. So 48.8% is my answer. Anybody need to ask about number 5? Okay, number 6. A bunch of bananas weighs 0.86 pounds. After peeling, the bananas weigh only 0.52 pounds. What is the yield percent? Okay, I need a percentage. Well, again, just like the previous 5 problems that we've been doing, percentage, the idea behind a percentage is it's a part of the whole, right? Part of the whole. So the question is, what's the part and what's the whole? Well, in a yield percent problem, what we're looking at, yield percent is the edible part divided by the as purchased part. Okay? And so the as purchased part, that's the whole, always. Right? Because that's what we buy at the store. We buy the whole thing. So we buy the whole bunch of bananas. Again, for the percent yield, for a yield percent, we want the edible part. Okay? That's the part we're interested in. Okay? So it's the edible part. So all I have to do is figure out then over here, my 2 initial values, the 0.86 pounds and the 0.52 pounds, where do those things go in my problem? Okay? So as I reread this problem, it says a bunch of bananas weighs 0.86 pounds. After peeling, the bananas only weigh 0.52 pounds. So what's the yield percent? Okay, well, 0.86 pounds, that was how much I purchased from the store. 0.52, that's my edible part. So 0.52 divided by 0.86. And again, that's going to give me a decimal number because this is part of a whole. So it's going to be less than 1, part of a whole. So we need to multiply that by 100 to get our label of percent. And so 60.5% is my yield percent for bananas, or at least for this bunch of bananas. Anybody have a question? Okay, flipping over to the back side of the page, guacamole recipe requires 25 ounces of peeled, de-pitted, and diced avocados. So that's the part that I need for the recipe. Okay. The question is, what is the minimum amount of avocados to purchase? So how much avocados should I buy if the yield percent is 63? Okay, so I've listed everything out here. Again, going back to our equation, the yield percent is the edible part divided by the as purchased part. Okay, the edible part divided by the as purchased part. By the way, before I forget to tell you guys this, on the test tomorrow, I will give you all this equation. Okay, you do not have to memorize it or worry about that at all. I'll have it right on the test for you. You just have to be able to know how to use it. Okay, so we need to figure out from over here what we have, what we don't have. All right, well, we know the yield percent, and we know how much is needed from the rest for the recipe. That's the edible part. What we don't know is how much we're going to buy. So we need to figure out the purchase part. So all I have to do is plug this into my equation more or less, and I'm good to go. But just like if you go back to these problems up here, okay, we had to multiply by 100 to get our percentage. So we have to do the inverse of that. We have to divide by 100 to get this into a decimal so that I can put that in over here. Okay, so this is 0.63. 63 divided by 100 is 0.63. And then I know that I need 25 ounces for the recipe. What I don't know is how much to buy at the store. So that's what I've got to solve for. Okay. All right, in order to get X all by itself, right now I have to recognize that X is in the denominator, and that's not good. I have to move it up to the top. So I'm going to multiply both sides by X. That way this cancels. And I'm left over here with 25 ounces. And of course over here I have X times 0.63. And now I've got X on the top, which I needed, but unfortunately I didn't get it by itself. It's got this 0.63 in the way. So I'm going to divide by 0.63 on both sides. And that will get X alone. And so I just need to divide 25 by 0.63. And when I put that into the calculator, I get 39.7 ounces, and I rounded that. Okay, so that is the minimum that I can purchase. Because remember, I'm going to clean it. I'm going to take it out of the skin. I got to take the pit out. And so I have to have more than what the recipe calls for. I've got almost 40 ounces. The recipe only needs 25. So that makes sense because the pit and the skin are, of course, going to weigh something. So I have to buy at least 39.7 ounces of avocado. Now, what are the chances that you're going to be able to go to the store and put avocados on the scale and end up with 39.7 ounces? Probably slim to none, right? So you can buy more than 39.7 ounces. That's not a problem. It's okay to have extras because you can always do something with that extra avocado. You can just eat it, or you can use it in something else, right? You can put it on a salad or a sandwich or something like that, however you like to eat your avocado. But you can't buy any less. Anybody have any questions about number 7? All right, number 8. A chef purchases a case of kiwis for a recipe. The weight of the kiwis was 3.76 kilograms. So that was the total weight of the case of kilograms of kiwis. It says if the recipe calls for 275 grams of kiwi, so that's how much the recipe needs, 275 grams. How many recipes? Okay, how many, what's the number of recipes that can be made given that kiwi has a 92% yield. Okay, so we're doing a yield percent problem, part of the whole again. So the yield percent is the edible part divided by the as purchased part. Okay. I know the percent yield. Of course, I have to divide this by 100 so that I can plug that in. So this is a 0.92. And I need to figure out what I know up here. Well, the problem told me that the case of kiwi weighed 3.76 kilograms. So that's how much I purchased, was 3.76 kilograms. So what I don't know is how much of the kiwi I can actually use out of the case. That's what I'm going to solve for. I know that it's got a 92% yield. I know that the case weighed 3.76 kilograms, so I can figure out how much kiwi is usable. So I'm going to multiply both sides by 3.76 kilograms. Of course, that cancels. And X equals 3,452. Okay, 3.4592 kilograms. So that's how much kiwi I can get out of the case that was purchased. Okay, because remember, we got to throw away that skin, that fuzzy part on the outside of the kiwi. Nobody wants to eat that part. But the question asked, again, how many recipes can be made? Well, in order to find that, I've got a little bit of a problem here because my recipe is going to be measured in grams and the weight of my kiwi is in kilograms. So the first thing that I need to do here is to convert my kilograms into grams. And I want to remind you guys, yes, 3.4592. That's right, Naisha. Yep. So the first thing that I need to do here is convert kilograms into grams. And so remember that we have to use a conversion factor. And there are two conversion factors to get us into between kilograms and grams. Remember, there's this one. There's 1,000 grams in 1 kilogram. And there's this one. 1 kilogram is 1,000 grams. Okay, so how do I know which one I need to use? Do I need to use the first one? Do I need to use the second one? Well, don't forget, I've been trying to drill this into your head for well over a week now. The whole reason that we started this unit with the domino game was so that you would learn that one rule, that whatever I start with right here comes down to the bottom. That was the whole point of that little domino game that we started at the beginning of the unit, right? So I need to use this conversion factor because I need kilograms in the bottom. So there's 1,000 grams in every 1 kilogram. So my kilograms cancels. And of course, this just moves the decimal. 3,459.2 grams. Okay. That's how much kiwi I actually have to be able to use after I peel them. Well, the question is, how many recipes will that make? Well, I can make one recipe out of 275 grams. So if I divide the total amount of kiwi I have by the amount of grams it takes per recipe, that will tell me how many recipes I can make. And when you plug this into your calculator, you're going to get 12 point something. 12.5 something, I believe it is. Well, If you think back again to the idea of this question, how many recipes can I make? Well, I don't want to make a part of a recipe. So I'm only able to actually make 12 recipes. I have to round down because I'm going to run out of kiwi. Partway through the 12th recipe, I'll be able to make 12, and then I'll have a little bit of kiwi left over, but I won't have enough left over to make another recipe. So I can only make 12 recipes. So pay attention to, what the question's asking you. If you were to give me a decimal answer on this problem, I would take off points because I can only make 12 recipes. Yep, I'm going to have some kiwi left over. No problem. I like kiwi. I can eat it. I can put it in Jell-O. I can do lots of stuff with it, but I can't make the other recipe. All right, number 9. Unless anybody had any questions on number 8. Sorry, I forgot to ask that. Anybody need anything with number 8? All right, number 9. The following ingredients list is given for a recipe that makes 144 cookies. Convert the recipe to yield 3 dozen. Okay. Well, this is a recipe conversion problem, and the recipe conversion factor is always the new yield over the original yield. Okay, the new yield over the original yield. So the original yield is what the original recipe was going to make, and the new yield is whatever we want. Okay, so what we want is 3 dozen, and what the original recipe called for said it was going to make 144 cookies. Now we got to be careful because 144 cookies and 3 dozen are not the same unit. Okay? This word dozen, of course, means what number? Type into the chat box. What does the word dozen mean? Yeah, 12. That's right. So 3 dozen is really 3 times 12, which is 36. So I want my recipe to make me 36 cookies, right? So when I come over here to my recipe conversion factor, what I want is 36 cookies. What the original recipe called for was that it was going to make 144 cookies. So 36 divided by 144 is 0.25. So this is my recipe conversion factor, 0.25. And so what I have to do is I have to multiply that times each ingredient. Okay, each ingredient times 0.25, and that'll tell me how much of that ingredient I'm going to use. So let's just go through a couple of these. For example, 12 eggs times 0.25. 0.25, remember, this is a part of a whole, is the same as 1/4. So what's 12 divided by 4? So in my new recipe, I'm going to need 3 eggs instead of a dozen. Another example. The original recipe called for 4 cups of sugar. So I'm going to multiply that by 1/4. So I need now 1 cup of sugar. Okay, the original recipe called for 2 cups of M&Ms. I'm going to multiply that by 1/4. So that is 1/2 cup of M&Ms. So you get the idea. I'm not going to do every ingredient. I just wanted to show you guys a few of them, okay? We're just going to multiply everything by 1/4, 0.25. Anybody need to ask me a question about number 9 or how you do the recipe conversion factor? Okay, again, that recipe conversion factor that I just boxed in, that equation, I'm going to give you that on the test. So I will have RCF equals new over old or original or something, you know. So you just have to use it. You don't have to memorize it. You just have to know how to use it. Okay, last problem is just like number 9 with a twist. It says the following ingredients is given for a recipe that yields 50 apple rolls. So this is the original recipe. And then it says convert the recipe to yield 15 rolls. So I want 15 rolls. So again, my recipe conversion factor is the new, which is what I want, divided by the original. So this is just 15 divided by 50. And that equals 0.3. So in this last problem, I'm going to multiply all of my ingredients by 0.3. And that's all there will be to it. Okay, multiply everything by 0.3. Anybody have any questions on the worksheet at all? Any questions on the worksheet at all? All right, I've got a couple of other things that I want to go over with you, just again, refreshing your memory. Just reminding you, like I did a few minutes ago, that there's lots of different conversion factors, and there's the reciprocal of every one conversion factor that you can think of has a reciprocal. So it all goes back to the domino game. Whatever we start with, we bring that to the bottom, and the finish goes on the top, right? And that is our new label. So whatever we start with, we move to the bottom, and then our new label is on the top, and that's the label that we want. Now, sometimes, remember, we have to use multiple conversion factors. I can't always convert from the unit I have to the unit I want directly. Sometimes I have to go through multiple conversion factors. So, for example, you might need, if you're going from a mass in kilograms to a mass in ounces, you would first have to go from kilograms into pounds, and then from pounds into ounces. So you would need multiple conversion factors to do that. And you just have to pick the right ones. So again, if I was given kilograms and I was asked for ounces, I would start with whatever my given information was in kilograms, and then I would need a conversion factor that goes from kilograms to pounds. Actually, you know what? Sorry, no, we didn't do a conversion factor that goes from kilograms to pounds. We did a conversion factor that went from kilograms to grams, and then we went from grams to pounds, and then we could go from pounds to ounces. So we would need all 3 of those conversion factors. Okay, and again, the numbers are on your cards. You can put them in. There's 1,000 grams in a kilogram. There's 454 grams in a pound, and there's 16 ounces in a pound. So, but those are all on your cards. You'll have them to look at. Okay, so make sure you know how to use those conversion factors to get from one unit of measure into another. And then let's see, another thing that I want to do real quick is we've talked about this problem a few times, but we've never actually done one together. So I wanted to actually do these problems with you, give you a set of data so that you would recognize this and know how to do it. So let's say I buy a bunch of bananas and I measure those bananas and they weigh, I've got 236 grams. And I've got 242 grams, and I've got 228 grams, and I've got 256 grams, and I've got 242 grams, and I've got 263 grams. Okay, so there's my bunch of bananas. It's got 6 bananas in it. And they all have a different weight. Okay, a few questions. And I want you guys to chime in here and answer these questions for me. First question. How do we find the range? Take the highest number and subtract it from the lowest number. You said that backwards, but you're on the right track. Because you'd get a negative number if you did that. But yeah, so we're going to take the highest number, in this case 263, and subtract the lowest number, 228. And so that will give us the range. In this set of data, is there a mode? Remember, mode was one of your vocabulary words. So, of course, you have to know what that means. Let's see, Will typed in it's the most frequent number. Yes. Do I have a number here that appears more than once? Good, Naija. Yep, 242. So my mode is 242. Excellent. All right. How do I find the mean? How do I find the mean? Add all the numbers together, divide by how many there are. Good. Okay, so I'm just going to take 236 plus 242 plus 228 plus 256 plus 242 plus 263. I'm going to divide that by 6 because there are 6 bananas. And that'll give me my average. Okay. So just want to make sure that you guys knew how to do all of those different things. Again, we use them as vocabulary words, and we'll need them at some point here in the semester. And I wanted to make sure that you guys recognized how do you actually use them with data. So there's some data, and we can use them. Okay. One more thing I want to do with you guys, and that is I want to look at the idea of yield percent from one other perspective that we haven't talked about yet. So let me do that real quick here. Yield percent. Remember, the yield percent is the edible part divided by the purchased part. Okay? So anytime we're talking about a percent, we're always talking about a part of the whole. The purchased is the whole. That's what we're going to buy at the store. And so that's the whole thing. And then the edible part, obviously, is the part that we want to eat or whatever. Okay. So one of the things that's kind of common in the culinary world is dealing with things like nuts, for example. Okay, pecans, pistachios, walnuts. There's all kinds of these different nuts, and they come in shells, right? So let's say I wanted to buy some pecans. I could either buy them in the shell or I could buy them pre-shelled already. Well, pre-shelled nuts are very, very much more expensive than whole nuts. Okay, so if you buy the nut in the shell and you shell it yourself, it's a lot cheaper than if you buy just the inside. And so it might be worth it, it might be kind of fiscally responsible, if you will, to buy the whole nut and shell it on your own. That slows you down from eating as many if you're buying them to just eat as a snack, but it also saves you lots of money. So pecans, let's say the pecan has about 25% of the pecan, 25% of the total weight is the shell. 25% of the total weight of a pecan is the shell. So if I ask the question, what is the yield percent? How would we go about solving a problem like this? If 25% of the total weight of the pecan is the shell, what is the yield percent? How do I solve this problem? Well, the answer to the question is, remember that a yield percent is all about the edible percent. Okay, that's what I'm interested in. What part can I actually eat? And so, as always, the total is equal to the sum of the parts, right? Well, what are the parts of a pecan? The shell and the part that we eat. Oops. The shell and the part that we eat are the parts of the pecan. So I can find the edible part if I know the total in the shell. Well, what's the total? What percent is the total? You guys hopefully know that 100% is the entire thing. So if I subtract the shell, which is 25%, then my edible part is 75%. So my yield percent for pecans would be 75% if 25% of it is the shell. Because remember, the whole nut is 100%. All right. Who has questions at all about anything that I've gone over and talked about here? All right. So yield means total is the question you're asking. Yield percent doesn't mean total. The yield is the dealing with the edible part of the total. So when you're talking about a yield percent, we want to know how much you can eat out of the whole thing. So you take, and it's typically done by weight. Typically, you take the amount that you can actually eat. So again, how much of the banana can I eat? And you divide that by the total weight of the banana and the peel. So anytime we're talking about a yield percent, which the part that we're interested in is the edible part. Okay. And that's what, when I did this pecan idea here, when I asked what was the yield percent, I want to know what percentage of the pecan can I eat? Well, if 25% of the pecan by weight is the shell, then I can eat 75% by weight of the nut. Okay. Did that clear up / answer your question, Naisha? Okay. Anybody else have any other questions? Okay. So I have a few things that I need to say. Number one, again, we've got a quiz tomorrow, right? And it's going to be over all this math stuff that we've been working on. So make sure you're prepared for that. You can use your conversion factor cards, okay? I've been telling you that all along. So make sure that you have them readily available tomorrow when you come to class. You're going to obviously need scratch paper and a writing utensil and a calculator to solve these problems. So make sure that you have that stuff ready to go when you come to class, okay, when the bell rings. When we get started here, make sure you have your writing utensil, your calculator, your paper, scratch paper to do the problems on, because you'll only be putting answers into the Google form that I've created for your work, okay? Also, there are several of you, and Miss Hall, if you're listening closely, you might have the list of students in front of you. You did earlier last period, of the students who still need to make up the vocab quiz from last week. So any students that are in the meet here that haven't made up your vocab quiz from last week, my plan is for you to do both quizzes tomorrow. There should be ample time, because that's all we're doing tomorrow is just taking quizzes. So there should be ample time for you to do both quizzes during our class meet time tomorrow. So be prepared for both the math quiz and your vocab quiz if you haven't done the vocab quiz yet. Also, there are probably some of you who did not do the exit slip from yesterday. So if you are in the meet today and you did not answer the exit slip from yesterday, you need to get that done. And in addition to yesterday's exit slip, I also put an exit slip in there for you for today. So go over to the classwork page. And I forgot to put the date on it, I think. Let me look back. Yeah, I forgot to put the date on the question. It just says calculate the mean of the following data. So you'll just look on there and open that up. And again, just do the math and make sure that you remember to include your units in your answer. Okay. And just do that exit slip real quick today. And then you don't have to turn in, you don't have to click on the turn in button for this document online because, you can use it to study. If you turn it in, you can't see it anymore, right? So I want you to have it so that you can study from it so that you're prepared for the test tomorrow. So once you turn in your exit slip, you are free to log off the meet and just use your time wisely if you need to study for tomorrow's quiz. So if you have any questions, now's the time to ask. Otherwise, get on your exit slip, and when you're finished, I will see you tomorrow.